Yeah.
Good afternoon. Thanks to everybody for coming. I'm John Craig. I'm from ATT. I'm a lead MTS working on the Akraino EdgeStack project.
And my name is Travis Broughton. I'm a community manager with Intel's Open Source Technology Center. Thanks for joining us this afternoon. We're excited to be talking about the new project that we launched in the last 6 weeks, the Akraino EdgeStack. This is a new project that we're working on in conjunction with, we launched it under the Linux Foundation, but we're working in close collaboration with the OpenStack Foundation. We're very happy to be here and happy for the reception that we've gotten at the summit this week. So in the last 10 years or so, a lot of enterprises and other large organizations have consolidated a lot of the computing capacity into the cloud using virtualization and other techniques to really centralize computing. But in the last year or two, the pendulum seems to be starting to swing the other way with a number of applications that are really more latency sensitive and are demanding more intelligence at the edge of the networks near where the data is being produced and consumed. And so we're seeing usages like autonomous vehicles, immersive experiences like VR and AR, the Internet of Things, NFV, a number of things that have a lot of requirement for sort of that carrier-grade reliability that telcos have provided historically for a number of new applications. And so this is driving this new methodology of computing that is becoming known as edge computing. So the Akraino project is intended to address some of those concerns. And our approach has been to look at the reusable components that are out there. We don't want to reinvent the wheel. There are a number of techniques that have been used in cloud computing around orchestration, provisioning, a number of different virtualization of computing and virtualization of storage and networking that are available for us to reuse and to integrate in a stack that is suitable for edge computing needs. And so we're looking at things under CNCF, under OpenStack Foundation. AT&T last week launched the Airship project. This week at OpenStack Summit, Intel launched or announced the Starling X project. These are a number of upstream infrastructure components that we hope to integrate in support of this end-to-end sort of edge stack. So operators who are deploying at the edge, we're not the only ones who have identified the building blocks that can be used, but a lot of people are going about it in different ways, and there's a number of stumbling blocks in everyone trying to assemble their own, roll their own stack from top to bottom using these components. And so having some generalized requirements around the scale of edge. Edge computing, I tend to think of it as almost a pathologically wide scale hybrid cloud. There are thousands of locations, potentially thousands of control planes that need to be seamlessly glued together. There's a need for simplified operations. In the cloud, you have generally a large data center where there's an operations staff on call that's always available to go address issues should they arise. At that scale, there's been a lot of automation to remove the need to do that in real time, but at the edge, the staff may not be anywhere nearby. And so the ability to have zero-touch provisioning, zero-touch operations, and overall life cycle is really magnified at the edge. The need for lower cost, again, with all of this, this sprawl of computing capacity, there's a need to minimize the total cost of ownership, the cost to roll it out and deploy it. And there are a number of edge use cases, but they share a number of requirements. And so with Akraino Edge Stack, our goal is to be the first open source community that's exclusively focused on integrating all of these cloud components into a cloud edge platform. We are also targeting the developer ecosystem. So one of the challenges with the edge applications is all of the ugly bits underneath, the complexity of the edge, the complexity of the orchestration layer, and of all of the number of locations. Being able to provide an abstraction layer, an API layer in a developer framework that will allow developers not to have to worry so much about the underlying infrastructure and really focus on delivering the business logic that will add value for the application. And whether it's a factory automation or a retail or something operated by telco, being able to look at those common requirements and allow developers that common framework that they can leverage. So again, Akraino is all about the edge. We're focusing in a few different areas. We want to have that fully integrated open edge stack, so that underlying infrastructure, CI/CD and tooling to take those open source upstream components and integrate them as they're available, but also a top to bottom blueprint that looks at the hardware and the software stack and provides a relatively small number, a manageable number of different blueprints that will be specific integrated hardware software designs that vendors can build on top of and developers can target to, collaborating with the upstream to meet those needs. We also want to develop a set of APIs and application frameworks working with third-party edge providers and the hybrid cloud models to provide something that is a consistent target. And then in some cases working on the development of the edge applications themselves where there's common requirements in terms of middleware and SDKs, having the VNF ecosystem similar to what's being done elsewhere in FVI. So we first announced the project at ONS, and we've had a number of vendors and operators who've expressed interest in the project. It was founded by AT&T, Wind River, and Intel through the Linux Foundation, but we're hoping in having sort of roadshows like this to attract other operators, other users. We want to have a very diverse community inclusive of operators and end users, developers, really to be able to design the right set of blueprints that target some compelling use cases that span industrial IoT, telco, and enterprise IoT. And so some of our key principles that we've adopted in support of this project, in terms of design, again, we want to have a relatively small set of configurations, have that be manageable, not millions and millions of different blueprints, but relatively small to reduce the overall complexity. Where appropriate, we want to go after cloud native applications. When things are being designed from the ground up, that seems like the way to go. But supporting legacy as well through support of virtualization within Intel and looking at what our IoT business is doing, the time-honored tradition of lift and shift that we used in the enterprise seems to apply in some cases in industrial IoT as well. Security is of top importance in the cloud, or I'm sorry, at the edge, because whereas in the cloud, again, you have a fortified data center, the capacity may be not in a secure room or not completely under your control when you're deploying at the edge. So securing the platform and services without being a burden to the application developer. We want to have autonomous and turnkey solution for service enablement. So that zero-touch provisioning, zero-touch management, that is, again, very important in the design of this environment. And the platform, the application assessment and gating, making sure that the application itself is fit to run at the edge, that it can tolerate the sorts of latency that it might encounter. So providing sort of an environment where those things can be validated. And then when building this out, having a low total cost of ownership, making sure that it's scalable and evolvable. Having lower latency, being able to place the applications at the edge and supporting high performance, high throughput, low latency processing. And having the design be overall plug and play and modular so that we can reuse those cloud components that exist in the ecosystem. Again, with operations, the zero-touch provisioning operations and lifecycle will help to address those goals of reducing cost. And then we want to be able to establish KPIs, make sure that the environment is delivering the right level of service that is required by the end applications. As I've mentioned before, we are looking at APIs and application frameworks as having an abstraction layer that can reduce the barriers to being able to develop applications on such a diverse set of hardware platforms and software stacks locations. And then a common platform and service orchestration model, looking at things like ONAP to deliver on that. Again, we view this as being complementary, not competitive or reinventing the wheel, duplicative of other adjacent projects. So there are a number of projects out there that we're looking at incorporating into some of these blueprints, both from the Linux Foundation and from the OpenStack Foundation, really being able to consume what's there and provide the value-added code on top as well as the glue layer to help assemble these stacks.
Thank you, Travis. So here's what we see the benefits here. First of all, having this stack is going to enable new business ecosystem and cost savings. So two fronts, really. New business ecosystem generates new revenues. Having a common stack will generate cost savings because we won't have vendors going off doing stuff that they try to take into an operator and then they have to retest everything because it doesn't match what the operator models are. We think this will benefit application developers, public cloud providers, suppliers, and I guess I talked about telco operators. So, just a little bit about optimal zones for edge placement. I mean, we see that the edge is not really, there's not just one edge. There's multiple edges, and there's different use cases for different, based on different requirements. So like in the past, the edge has been more or less the centralized clouds of public and private operators. Now we see that the edge is moving out, and there's two zones that we see as optimal for right now, right? There'll be multiple edges, but the two zones that we think are most fruitful to focus on right now are going to be what's called the telco network edge. Telcos have a lot of real estate in central offices and cell towers and wire centers and spread all over the country in a distributed manner. And there's enough real estate to be able to bring the processing and latency down to where the use cases, particularly things like 5G and some of these use cases will be possible. And the other zone is customer premise. We know there's a lot of enterprises that are interested in processing at the edge. There's already service offers or offerings from various telcos like Verizon and ATT and other operators that places equipment in CPE equipment and manages CPE equipment on customer premise. So that's the other area. And also you can see here the latency estimates. These are really just estimates or averages, but bringing latency down to in the range of under 20 milliseconds is close enough to meet a lot of the edge use cases. It won't meet all of them, but it's going to meet a lot of them that are viewed as early possibilities for edge computing. So talking a little bit about methodology and how Akraino plans to release its edge stack. We pretty much are following a methodology based on blueprints, where a blueprint is composed of a set of elements. First element is going to be the reference architecture, and I'll show you just a proposal on what might be a reference architecture for an edge stack. But the reference architecture defines kind of the high-level building blocks that are used to construct the edge stack. Declarative configuration is a lower-level detailed specification of what are the specific elements that are used, what are the specific configurations that are used, things like that. CI/CD and testing tools, so anything that Akraino is any blueprint that we're coming up with, the intent is that we would put it into a CI/CD configuration so that we would be testing it and deploying it, and not just writing down a specification that somebody takes it and has never actually been tried in any lab or anything like that. And the fourth element is a pod, point of delivery, and I'll show you the next slide, I think, covers that. So that's kind of what we envision as our delivery vehicle on how do we release our edge stack. So this just gives some examples of a pod or a point of delivery, which is some things that are being used in-house in our company and possibly can be used in the industry. Kind of looking at various kinds of use cases and various kinds of scenarios where you might have a requirement for a large pod, where this would be, like in this example, 6 racks with network gear and compute gear and control plane and compute plane or data plane. And this is envisioned to be used for use cases like 5G and other kind of telco-based use cases. That would cover, for example, a large metro area that has a lot of density of users and things like that. There may not be that same requirements for that much computing. And so there's other pods that have been envisioned, like a 3-rack pod or even a 1-rack pod. These would cover the smaller population areas or the smaller use cases. We have 2 things over here on the right that are not really well specified right now. The even smaller configurations that cover some of the edge use cases, for example, like IoT, aggregation, or smaller types of edge applications. So this is kind of the proposed building blocks or reference architecture that we talked about. And that's kind of the stuff in the middle here. You can see on the left-hand side, we define a CI/CD that would cover the continuous integration and deployment to perform testing for the building blocks. And basically, starting from the bottom, you start from the hardware. And we talked about the pods. There's different kind of pods that would be different kind of sizes of deployments. That's just the hardware in a specific kind of configuration. Edge platform software, which is the components that actually will provision the hardware, put the operating system on it. They'll add they'll add things like Kubernetes, Docker, OpenStack. They'll take care of the full life cycle. So it's not just they put it out there and then that's the last that you hear about the platform. The edge platform software is responsible for life cycle management of the platform. And if the orchestration, there's a layer for orchestration. This is primarily for VNFs. And ONAP is going to be part of the specification, which is already in the community. It's a Linux Foundation project for dealing with service orchestration. We think there's going to be an edge application orchestration, which might be different than VNF orchestration. This is something that we're going to look to the community to help with. As Travis mentioned, we envision to have edge application and APIs. So it's like we said, it's a full stack. It's not just platform. It also includes applications. And on top of that, we have things that allow people to operate and manage Akraino deployments, including a portal, dashboard, GUI, and a workflow. On the right-hand side, you can see this, some of the components. For example, Airship, which has already been announced, is a proposal for the Edge platform software, along with Starling X, which is another similar kind of OpenStack deployment. There's components also for things like fabric orchestration. Right now, we don't have that, but we do have a plan that would include network fabric orchestration, and inventory is the other one that's kind of a requirement. But you can see there's going to be a bunch of different tools that are going to get added into the configuration. So ATT has made a number of contributions to kickstart this community. First of all, we will have demonstration of a working blueprint of an Akraino edge stack targeted now for near the end of June. We have real-world edge architecture and knowledge. We'll have a blueprint based on Kubernetes, OpenStack, Airship workflow with a GUI. Integration of the platform lifecycle tools, VNF orchestration based on ONAP, some sample edge applications, CI/CD testing and documentation. And in the future, we do plan to include some other components. Narrate is an inventory tool, and Pink is a network fabric orchestration tool. And Danos is a white box network operating system, which is also a project sponsored through Linux Foundation by AT&T and some others. Labs. So for CI/CD, we need labs. And although Linux Foundation will have basic labs to support CI/CD for definition of testing and a portal and things like that, we do expect that there will be multiple blueprints, and there's going to be a need for community involvement to support multiple labs to test various kinds of use cases and various kinds of hardware and software and things like that. So, and just want to emphasize this is going to be a community. We are really looking to the community to drive interoperable edge APIs. For more information, please visit. So
that's all we have for today. If you have any questions, please use the microphone so that your questions can be captured on the recording. We also invite you to join us tomorrow. We'll have a Birds of a Feather session in the morning, which is back-to-back with the Edge Working Group's Birds of a Feather session. So we'll have extended conversation there as well. Yes?
John and Travis, excellent presentation here. So my question is around security, right? So where do you envision some of the security checkpoints going to be in the edge stack? Like some places you may not have an R-leaf, or it's only layer 2 connectivity coming through the access. So.
Boy, that's a detailed question. Security's got to be layered, right? So it's not going to be sufficient to say there's an external firewall and that's protecting, right? So hardened components. Starling X Wind River has a hardened version of OpenStack. The Airship has got hardening in it, and there are built-in components such as AppArmor, SecComp, things like that have to be baked into the configurations.
So what about the VNF security? I mean, so you expect the VNFs to bring their own security suite?
If it's an edge VNF, it is got to be responsible for that, right? I mean, the VNF, the platform will have security to put walls between various VNFs and things like that in a tenant model. But if a VNF has requirements to be accessed by external customers and things like that, they are going to have to bring the degree of security there, right? Same as if they're a PNF.
Thank you.
Yes.
Hi. I missed the initial few minutes of the talk, so apologies if it was covered. Is there an emphasis on open source to be considered part of that stack that you had?
Yes.
Question one. And question two is, what's in it for AT&T to make all of this open source, or
Well, it's not just ATT, right? So it's ATT, it's Intel, and we expect the community also to pitch in.
Sure.
The advantage to ATT is, I mean, today we get components from suppliers. They may have tested it in their lab with their configurations, with their hardware. We bring it in-house. It doesn't quite match what we do in our lab with our hardware, so we retest. And we go back and we say, well, this doesn't quite work. You need to make some mods to it. And then they go back, and 6 months later, they bring us something else and things like that. So the expectation is that this will allow us to have a much more efficient approach to getting components that are going to be useful.
But doesn't it give equal access to a competitor to the same set of technology?
Yeah, but that's the power of the community, right? Okay. And we would expect the vendors to really, this should be very efficient for the vendors too, because then they're not producing 2 different configurations for 2 different, telcos, or 10 different telcos, whatever.
Understood. Thank you.
Yeah.
Okay. A good presentation. I have a question, not so much for Akraino, but edge computing overall with the high throughput, low latency type applications.
Yep.
What are your initial thoughts on design for geo-resiliency? So failure of an edge cloud, shifting traffic to an alternate cloud. With an edge, it might be a more difficult situation.
Well, I think geo-redundancy is really a critical issue for any edge applications. Yeah. So edge applications have to be planning with a cloud mentality that this might happen, right? Whether the platform should provide geo-redundancy, they should provide ability to move IP addresses and things like that from one place to another, or DNS names, things like that. But it's still got to be, a lot of it's baked into the application, I think, the VNF design or the VM design.
Although I would say, I think part of the goal is to abstract away some of that underlying ugliness, so that to the extent that we can provide some best practices, having a common set of ways to kind of code to that. That's not necessarily going to be feasible for every sort of application, but providing some ways that allow the application developer to worry, again, more about the business logic, to be able to abstract away some of those things.
Okay. Thank you.
It depends on state, largely. A lot of things are heading towards native stateless scalability, so it depends on the app that you're talking about. If it's stateless, Akraino makes it easy to just deploy wherever.
That's a very good segue into my question, actually. Could you speak a little bit more about how Ceph is being used, what storage services you're using it for, and kind of the VNFs, which may be more storage intensive, and how that relates to the project?
So initially, right now, at least in our in-house, we are using Ceph for orchestration layer, which means Maria database and things like that are used by OpenStack. Tenet is defined to use ephemeral storage based on local disk, and Cinder volumes are deployed on top of Ceph. So if they need a Cinder volume, they would get that through Ceph. Most of the VNFs that we're working with initially are not storage intense. I think if we were doing a CDN, we would not probably use Ceph. We do have CDNs deployed on OpenStack, and they don't use Ceph. They use local disks.
So for the CDNs use the local disks?
Yeah, right now. Yeah, right now they do.
All right, thank you.
Great presentation, by the way. Just wanted, I'm on Network Operations Center for multiple municipalities. one of the things there I'm trying to get my head around this week is with edge computing, with things moving out to the edge, what kind of monitoring systems do you think are going to be in play here? I just wonder if you can speak about that a little.
So I think for massive scale edge systems, monitoring systems are still to be developed. For the stuff that we're looking at right now, we do have monitoring coming off of the airship with tools like Prometheus,
Right.
which then push alerts or push data into more traditional operations.
Right.
Because our operations guys now work off tickets, and they get that through systems that are legacy systems.
And I'm familiar with that one. And I think the other one, Manaska or something, it's the other open source monitoring system I hear about here. Is that something you see playing in this world?
I'm not really familiar with Manaska,
Manaska.
so I'm not sure how to answer that.
Okay, thank you.
We are open source and community based though. So if there's someone who has that knowledge and has a strong advocacy for it, we would welcome that within the community. All right, if there are no other questions, thank you for your attention today. Thanks for your time.